afternoon, ladies and gentlemen. I'm John.
I'm David.
And we're here to talk to you today. What is this today?
Story time.
Story time!
Story time.
I don't think we've done.
You know, I've not done a story time. Guess we're going to talk about Museum of Follies today.
Museum of Follies. This is actually not Museum of Follies.
Yeah,
This is,
you're right. We pushed through this one.
we pushed through. This was, but I will say this was like on the sidewalk in front.
Yeah, it was on the loading dock of the Museum of Follies.
Better yet. It was packaged up and ready to go. But and what we're talking about today is something that's used in ASTM 309 and 1315, and it's normally used for membrane forming curing compounds. And the procedure is ASTM 156, which stands for Standard Test Method for Water Loss from a mortar specimen through liquid membrane forming curing compounds for concrete.
Ooh, that's a mouthful.
That's a mouthful.
Yeah.
So, David, why don't you take us through what is the C156?
C156. Simply, you have the specimen with the membrane forming compound, or you can actually test without it if you want to test just admixtures or whatever. But it's a very complicated setup. You have three boundary conditions to meet. You have the temperature, which, as I recall, is 100 degrees Fahrenheit.
Plus or minus 2 degrees Fahrenheit.
Thank you very much. I make no claim to be the scholar. I have to look it up every time.
Yes, sir.
We have
Relative humidity.
relative humidity, which is 50%.
Relative
40%?
humidity was 32% plus or minus 2%.
Something like that. That sounds vaguely familiar.
Don't quote us on this. If you're doing this test, always look up the ASTMs.
Yeah, I make no guarantee or warranty on what I say about ASTMs.
Yeah.
I look them up every time.
We are the experts because we look them up every time. You know, there's a joke about that. I'll tell you later.
Yeah, there's a story about that too.
Sure.
So, and also you have the evaporation rate.
2.4 to 3.2 grams per hour
Right.
of evaporation loss.
Evaporation
or
rate.
Weight loss due to evaporation.
Right. So, I mean, that seems pretty simple. You look in the catalog, you've got a temperature controller.
No, it doesn't. It does not seem simple.
You look in the catalog, you've got a relative humidity measurer.
Sure.
Yeah. And then evaporation rate, that's
It's simple.
not so easy. That's not so easy. So we bought a big box.
We bought a bit insulated.
Insulated box.
Somebody drilled through it and had a whole bunch of Freon sprayed in their face. So we had a hospital visit. No, it doesn't matter who it was,
Now,
but
that goes in the Museum of Follies.
that goes in. That was awesome.
That goes Museum of Follies.
And then the design of it, we had a technician who, had free reign, and that technician for one of the panels used particle board.
Right.
And then,
which was just absorbing all the moisture.
well, then that technician cut the particle board with an edge grinder too.
Yeah. We've got multiple Museum of Follies stories. Let's get back to the action. So we bought those controllers.
Bought the controllers.
That would control the heat. We control the relative humidity,
And
we had to work out the evaporation.
one of the things that we did that I think was different from all other projects that we might have done in the past is we started hiring people to help us create the elements for the C156 when we knew that our precision was not good enough.
Right.
So my precision is maybe half an inch, 1 inch, plus or minus.
You're talking about cutting precision.
Yes.
Construction. Yeah.
Construction. David, yours is like 1/8, 3/8 of an inch.
Yeah, an eighth. I'm down to about an eighth these days. Yeah.
Uncle Richard is like 1/64 of an inch. Right? And then Mike is like 0.0000001.
Yeah, every time I talk to him, he has to explain to me what thou means.
So we got Uncle Richard to help us out. We got some plexiglass, and he really that actually made a huge difference for us in our precision in the equipment in California.
Yeah, it did. The design concept that we had was that we would have a chasing philosophy, that just like a home thermostat, that if it got down to the lower boundary of the heat, then the controller would turn it on and heat it up.
Right.
But what we discovered was we were using heat elements designed for rooms in a
very small.
2 by 4 by 3 foot volume,
Right.
and it had a tendency to overrun.
Right, and then we also had a dehumidifier and a humidifier
Right.
that couldn't be directly on the samples, and then we needed an evaporation controller, wind controller, that needed to be equally spaced along each sample in the same direction.
Right. So we got some nice little 12-volt computer fans for the control the evaporation rate.
Yeah, we had a dehumidifier and a humidifier, which were not directly on the sample.
Right.
That actually gave us a nice circulation effect, especially with the fans that we used.
Right.
And then a ceramic heat. Oh, just for the love of Pete, we had a ceramic heater. Just silence it when stuff happens. We had a ceramic heater in there that we had to circulate to, and we can only ramp up and break. We were chasing everything.
Yeah, we were. We discovered even in that small volume, there was a fairly large gradient coming off of the ceramic heater.
Right.
It was, it could be 130 on one side, and less than 2 feet away, it could be 100.
Right.
There's a tremendous gradient. So, as you described, we had to break all that up with fans and circulation and whatnot.
And then what we found out later is you need a special calibration cup.
Oh yeah, had to talk to the banker about that.
The banker had to talk to research, had to talk to Whitney. Let's just say it how it is. So, like Whitney asked David, hey, can you put a budget together? And we already did a video on how much it costs.
Yeah.
But, and the cost thing, that's really a David and Whitney resources conversation.
Yeah.
But it came to our side, we were trying to create a precision piece of equipment without spending $40,000 to $50,000.
Yeah.
Because that's what it cost if we were to buy it retail.
Right.
Now, I think when it came down to it, we were somewhere shy of $1,500 for everything.
For the equipment itself.
For the equipment.
Right.
For the hours.
Let's not get into that.
So once, but no, we have to get into it. I think that's the next part.
Right.
Because we had a setup.
Right.
We had to make that window, those 3 changes, or those 3 boundary conditions. And we were creating our own problems by using the particle board, by having the plus or minus half inch, plus or minus 1 inch. So we got all those things taken care of by getting very expensive plexi, by using somebody who is precision when it comes to designing, building, and making things, or designing, developing, and making things.
Right.
The last part of it came to
Calibration.
our patience and our perseverance, because there were evenings where David and I sat there like this. You can only, when we originally started taking measurements with this steel cup that was a very specific steel cup, $200 or $300, you can only take measurements every hour.
Right.
That means that we couldn't really make changes outside of that hour window. We had to make a change, let it calibrate, and then watch it for an hour. So David and I would sit there, and we had relative humidity sensors and temperature sensors.
Oh yeah.
So we could watch things change, but it was really just, and then you had to do it in every position. And every position had to be the same.
Right. Took a while.
But patience and perseverance and a very, very forgiving resources department.
Yeah. It reminds me of the old interpolation strategies where, there's high and there's low, so you go in the middle, and then there's high, and then you go. It was kind of like that.
Yeah, and then what we found out, one of the things, and we've got to end this here in a second, one of the things that we found out is that if you made too many changes at one point, it's a one parameter change concept.
Right.
Now you could do this, and you can keep narrowing your fields, but if you make too many changes at one time, you really don't know what changed had an impact.
Right.
Sometimes we'd get ahead of ourselves.
Yeah, we went up in that data cloud. We weren't sure which direction we were moving.
And then sometimes we'd open up the lid while the system was on, and that threw the entire system off. So then we had to shut it down, let it cool, come back the next day.
Yeah, we had to write a protocol for that because, as you said, if it was running and we opened the lid, it would sense that it was way too cold.
Right.
It would fire up that ceramic heater, and then when we closed, it would overrun the specs.
And it would constantly do that until it got up to 120 degrees.
Yeah.
I remember we came in one morning, it was 150 degrees. Ah! So, what I learned, and I think this is where we should end it off, our lessons, with the trials and tribulations, I learned that if we did not follow a linear path, that if we tried to do the kitchen sink with this and without going that linear path, we often ended up back at the beginning of that linear path.
Yeah, that's right.
Patience and perseverance and honesty to the phases of development was key. And man, did we learn quickly when we didn't respect that critical path.
Yeah, I think that's right. I think that's well stated. That you know, it's a crawl, walk, run situation.
Right.
You've got to take very small steps.
Right.
And I think your point of moving essentially one dimension at a time, one direction at a time. There is some relation between temperature and relative humidity, but still, I think you can't get up in the cloud and try to move multiple directions. You got to go north and then west and then a little bit south and then back north.
And you know, I'm excited for our next video. So hopefully y'all learned something today.
Yeah.
I'm excited for our next Museum of Follies where we talk about the freeze thaw. Because you and Whitney already talked about it,
Yeah.
but I would like us to talk about,
Okay.
you know, the process. This is a really good idea, Alan.
Yeah.
So thanks for joining us today with our story time.
Story time.
Let us know if you have any concrete questions or any technology concerns.
Or if you're looking at designing something, we have opinions on that.
Oh, do we ever. So, have a great day. Don't forget to like and subscribe. Ding that bell for notifications. Go Concrete!
Feed asphalt!